Hello everyone, this video is about examples about Chapter 7, the three cases. Example 1. Consider the large hospital that wants to estimate the average length of stay of its patients, mu. The hospital randomly samples 100 of its patients and finds that the sample mean length of stay is 4.5 days. Suppose it is known that the standard deviation of the length of stay is 4 days. What is the 95% confidence interval for mu? And because the sample size here is 100, we will consider as case 1, large sample mean problem, and we can use the formula for case 1. And note that if sigma is unknown, we can use the sample standard deviation instead as. And x bar is the average of the sample, 4.5. And z-score according to 95% confidence level is 1.96. And n is the sample size, 100. So the result is 3.72 and 5.28. And lastly, we better to interpret the result. That is, we are 95% confident that the true mean of the length of stay of its patients is between 3.72 days and 5.28 days. So this is case 1. Here is another example. Suppose a manufacturer of printers for personal computers wishes to estimate the mean number of characters printed before the print head fails. The printer manufacturers test 15 print heads and records the number of characters printed until failing for each. This 15 measurement in millions has a mean 1.24 millions and standard deviation of 0.19 millions. Form a 99% confidence interval for the mean number of characters printed before the printhead fails, and also interpret the result. And we notice that the sample size here is 15, which we consider as case 2, small sample mean problem. And the degree of freedom of the t-table, it will be n minus 1. N is 15, so 15 minus 1 equals 14. And we look at the row 14. And the question asked is the 99% confidence level. So we look at the bottom and find 99% confidence level, and the crossing is the t-score. So the crossing is 2.977. So that we can use the formula to calculate the confidence interval. X bar, the sample mean is 1.24, plus minus a t-score we found in the t-table is 2.977. S is the standard deviation, 0.19, and square root of n is the sample size, 15, so that you can have the result. And also, it's better to interpret the result. That is, we are 99% confident that the true mean number of characters printed before the printhead fails is between 1.09 and 1.39 million characters. So this is case 2. Here is another example. The BEBR at the University of Florida conducts quarterly surveys to gauge customer sentiment in the Sunshine State. Suppose that the BEBR randomly samples 484 consumers and find out that only 157 are optimistic about the state of economy. use a 90% confidence interval to estimate the proportion of all consumers in Florida who are optimistic about the state of the economy. Here, the question asks about the confidence interval for the proportion. So this considered as case 3, large proportion problem. And we need to find out p-hat. P-hat is the sample proportion, which equals to x, the number of successes, divided by n. N is the total number. So here, the x will be 157 who are optimistic about the state of economy. N is the total number, 484. So we can calculate the p-hat first. It equals to 0.324. And then we apply the formula. Z-score here, according to 90% confidence level, is 1.65. So you can have the result 0.289 and 0.359. And lastly, it's better to interpret the result. That is, we are 90% confident that the true proportion of all consumers in Florida who are optimistic about the state of economy is between your result. And because this is a proportion or percentage problem, and we can also say it's between 2%, that is between 28.9% and 35.9%. That's all for this video.